Hi, good day everyone. Welcome to the .NET Working Group session at IETF114 hybrid meeting. Welcome everyone who are in person in the meeting room in Philadelphia and also online. We are chairing the working group together with Lou Berger and I'm János Farkas. And many thanks to Ethan for being our secretary and taking care of the job minutes and so on. You find the information at the usual places. I don't go there, but I would like to remind everyone to the Ietf Note 12, which is our rules of way of working operation. And I would like to also remind everyone that what is being said here is getting minuted and becomes part of the permanent record of the IETF as a contribution. If you are not familiar with Note 12, then please go and double check. Also, a reminder on our guidelines in terms of behavior, like we expect everybody being familiar with it and expect to behave professional to the other people, the other contributors. As for attendance in these meetings, a couple of hints on this slide. In-person attendance, please join Meetaco either from your phone via Meetaco Lite, which gives you the opportunity to control the slides if you are presenting, for instance, or if you join the full Meetaco, then please pay attention not to use the audio and the video. And also very important, please wear your mask. That's how we run and how we have this IETF. As for remote participants, I think we are all very familiar with it in the past 2 years. Oh yes, that's a good point. That we will have a couple of questions to the group, and we will use the polling tool of Meetaco. So we would like to ask everyone to join for that reason as well, the Meetaco. Yeah, the QR code is on the screen if you are in person on the right-hand side to you. That's an easy way to join, or you can join from the agenda page. The blue sheets are automatic via joining Meetaco, so you don't need to do anything extra. And we also use the chat. For example, you can just use what we have in the Meetaco. Note-taking and minutes is a joint effort. So I would like to encourage everyone to join and add on and go and double check if you say something that it's been captured correctly. So the link is on the screen, and also you can find it from the agenda page and so on, and the other usual links as well. Here we are on Thursday at the DETNET session, but on Tuesday we had a joint session with the PAS and the Mpls working groups hosted by the PAS working group, and thank you for that arrangement. These discussions is about the evolution of the Mpls data plane, and this is one of our data planes in DETNET, so we pay attention that it remains good for DETNET. That's our main interest. So thanks everyone contributing to that and for the effort. We have a packed agenda, so we will pay attention to the time, and we ask the presenters to also pay attention and stick to their allocated time slot to let everyone have their slot and speak. Update on the status of our working group. We have 2 documents for which publication has been requested. The first one on the screen is the bounded latency draft. which got into the RFC queue, editor queue very recently, so heading towards the publication, and the Yang draft is the next one in the queue towards publication. We have a document in working group last call, the OEM framework document. The last call closes on the 3rd of August. We will get after this intro an update on that, and I would like to encourage everybody to review and comment. It is really high time. We have a draft which is a candidate for working group adoption. The IPR call process has been or is being ongoing, and we are going forward as usual. And we have two drafts, working group drafts, that are not on the agenda at this meeting. One is the controller framework, which we should come back and maybe touch upon it a bit later at this session. And one of the new ones, the DETNET Pre-Off via Mpls over UDP/IP. We have received a liaison letter from ITU, the study group 13, question 6, I think. Yes, question 6. We have been in liaison exchange with them, received one formally for information. We provided response to their work on deterministic communications. And we have received now this new liaison for information with 3 attachments. You can find the link via this stack or the other ways, the typical ways. Please check. And if we would like to respond as a working group, we can develop a response on the list. One significant step happened since the last IETF is that our charter has been approved, updated and approved. The approved was the new step. We have been discussing the update. You can see on the screen the actual changes. And as we have been discussing, the intention behind the update is to address sort of enhanced requirements towards DETNET, and to address these requirements to enable the development of queuing solution. We will have contributions on this later today. Milestones, we have just recently updated the milestones in the beginning of the week, capturing our progress. The blue ones on the screen are the actual changes of the dates, just to adjust, like past dates are not valid or were not valid. And we should, I think, try to pay attention to move the work forward to meet these milestones, and I think it's a good motivation. Also, a reminder on the IPR disclosure process. It's very important to disclose the IPR, and the last step is a bit newer than the rest, that if there's a new author, then we ask the disclosure. As for progressing our work, we have the virtual possibilities in between the IETF sessions, like we have been leveraging the working group WebEx. We can do that for other topics. Most recently, it has been the OEM, progressing the OEM drafts. We had bi-weekly meetings, and upon request, we are happy to set up working meetings or interim meeting if that fits better. Please feel free to contact us, working group chairs, and we figure out how to set it up. That's as for the intro. Do you want to add anything? Okay, so let's move on to the first presentation. You can just tell me when to go next.
Okay, thank you. Can I take it up? Or?
You don't need to.
I'll feel more comfortable. I'm sorry. Okay, next slide, please. Thank you. Okay, so we have 3 documents, working group documents, in the framework for DETNET. As you've seen that this is in a working group last call, and of course appreciate your comments, reviews, and response to the working group last call. And 2 documents that analyze applicability of existing OEM toolbox for IP data plane and Mpls data plane to the specifics of the DETNET architecture, specifically that we have 2 sublayers, forwarding sublayer and DETNET service sublayer. So let's take a look at what we have. The framework document lists general requirement for the DETNET OEM that is executed between DETNET maintenance endpoints, and requirements specific for proactive and on-demand monitoring and measurement OEM methods. For the active OEM, also we recognize that some of the tools are used as troubleshooting, mostly it's on demand, or proactive for longer lasting test sessions, and they may be configured and to be instantiated and activated upon the service being brought up. Active OEMs should support active and passive, and hybrid OEM are identified. Active OEM, it's using specifically constructed and injected in their network test packets. Passive, it's we are more familiar with their SNMP queries, but at the same time that can be based on notifications or RPC with their using based on a Yang data model. And hybrid, it's sometimes characterized something in between. So there are mechanisms that combine elements of active OEM and passive, usually with a minimum modification of the data packet to provide simplified identification of their marked packets, thus allowing on-path telemetry information to be generated and collected and at the collector side for network analytics, and possibly used for close network automation loop. So in addition to supporting unidirectional OEM methods, such as a continuity check and packet delay loss measurement, in some cases for the DETNET, there is interest to support the bidirectional net flows. Next slide, please. So as I mentioned that we identify their DETNET architecture identifies their 2 sublayers, the forwarding and service sublayer. For the forwarding, it's important is to be able to do path MTU discovery and use remote defect indication, so that the remote peer can indicate their loss of path continuity. That's usually how it's done in BFD. Also support monitoring level for path segment OEM. Next slide, please. So for the service sublayer, we identify their use of pre-auth or packet replication elimination order preservation subfunctions that can be instantiated in a DETNET domain, and that's what they're requirements for the DETNET, for the DETNET sublayer OEM to do discovery and functionality verification of the pre-auth. Next slide, please. Okay, now we next step would be to talk about and discuss their DETNET and IP data plane. So the well-known mechanisms are such as the ICMP that we usually refer to as ping and trace route, well-known tool for path continuity detection and the troubleshooting defect localization. Also, it's a BFD, it's a bidirectional forwarding detection. And for performance monitoring, it could be TWAM, STAMP, or some other protocols. The challenges here is that these are, as in case of ICMP, is based on IP, or a BFD, they're using their UDP protocol as a transport and well-known UDP ports. So they're mapping to the particular DETNET flow, and the forwarding flow. It cannot have, if the DETNET flow identified based on a 6-tuple, so the mapping is probably could be an operational challenge. Yes, it's possible, it's doable, but so the operator might be aware of it and use appropriate mechanisms to do their correlation so that OEM is used to monitor a desired and targeted DETNET flow. Okay, any questions? Okay, let's move on. Next slide, please. Okay, so one of possible methods of doing active OEM in a forwarding sublayer in IP environment for DETNET is to use DETNET is in UDP encapsulation. So the DETNET flow itself is encapsulated in the UDP tunnel, and then active OEM is encapsulated in the same UDP tunnel. So thus we ensure that in the forwarding layer they are fate sharing because they use the same 6-tuple. Okay, questions, comments? Okay, we'll move on. So
yeah, I guess I'll.
Sure.
In the past, we've talked about using aggregated state to not have to do an exterior encapsulation, and we've not had any firm proposal on that. So it does not. It's not reflected in the current document. So go ahead.
Yeah, actually, if we look at the previous slide, so that's where, okay, that's how existing tools without any encapsulations envisioned to be used. So basically, there are a lot of operational mechanisms to establish relationship between monitored or DETNET flow that intended to be monitored and OEM mechanisms, because the problem is, or the challenge is that we're using specific ICMP protocol, specific IP protocol as ICMP, or we're using particular well-known UDP port for different OEM protocols. BFD is distinct from TWAMP. STAMP can use the same UDP port, well-known 872. Okay, so because we already are bound by OEM protocol, what destination port, UDP destination port we use, and that the fact that we're using UDP transport. So it requires special provisioning on within a DETNET domain on a forwarding sublayer to establish this correlation so that test packets are treated the same way. One way of helping is, for example, it could be use of source port numbers or UDP source port numbers to help to establishing. And to that degree, we have this discussion reflected in DETNET for IP data plane document. But again, we are not prescribing how to establish this correlation, because I believe this is an operational issue and there are many ways to do that.
Sure. And on the next, can we go to the next slide for a moment? It would also be possible to have that active OEM in a new UDP tunnel and have the DETNET flow outside and have, through control mechanisms, through the controller plane, have the association. And we haven't seen that one talked about either.
Okay, that's interesting. So basically, to have all different active OEM protocols in the same UDP tunnel and then map that UDP tunnel.
Exactly.
Oh, okay. Yes, that's something different. And yeah, that's a good idea.
I thought we had, it had been discussed, but never actually documented.
No, actually, I think that, okay, then I missed that.
Okay.
Because that's a little bit different. That's an interesting idea, because as you see, okay, I have to say, I haven't thought about it.
Okay, that's fine.
It's a good idea. I'll make sure that will be included in the next version of DETNET and IP.
Great, thank you. We also have Pascal.
Pascal, go ahead.
Yes, thank you. So basically, we need that correlation that's clear. For IPv4, I understand that we are stuck with what you're saying. For IPv6, we have the possibility to tag the packets in an option header, like hop by hop. And in that case, if the DETNET operation is dictated by the hop by hop option, as opposed to the flow, we can effectively encapsulate multiple flows into a single with the same hop by hop option. The cool thing about using an option is you don't have to create an extra UDP caps, and you don't have to have the silicon go all the way into the packet after the UDP to find which DETNET operation you're looking at. If it can all be signaled right after the IPv6 header in a hop by hop option. So that's why I have this draft. I mean, we have not discussed it much, but the whole reason of this hop by hop, or it can also be a destination option. I mean, depending on what you do. I mean, if you look at the draft, you'll find more. But basically, the flow is something. It's an application layer concept. The recognition of the network operation on the packet is a network concept. It doesn't have to be signaled by the application layer. The application layer can have multiple flows, and it's up to us to decide to tag the treatment that we're going to give to those flows. That can be OEM, that can be data, and that can be multiple flows being merged in one big pipe. So for us, it's this pipe that has this procedure. We need to tag the packet with the pipe and then do based on that tagging. We can do that in V6.
Okay, Pascal. I think that there's still a need for external tunnel, because the identification of or demultiplexing of active OEM protocols is based on well-known UDP port number. So if it's not an external UDP encapsulation, then their destination port number has to be for the given protocol. And then it's basically the case of previous slide when we have what I refer to as existing OEM.
Yeah, that's exactly what I was telling you. We can solve a lot easier because you don't have to change your packet. You just tag the packet with an IP hop by hop header, but your all OEM packet remains the same. But the DETNet treatment does not depend on the ports anymore. It depends on the hop-by-hop header. So they get the same treatment as long as they have the same hop-by-hop header and you use the port that you like. You do everything you like, really.
Maybe can we continue this discussion?
Yeah, we need to talk about it because I don't think that the processing of OEM protocols with hop-by-hop header by transit nodes have been defined. Because for example, in the case of BFD, like well, single hop, obviously it's considered to be for single IP hop. But if we talk about multi-hop, I don't. Oh, need to look at, and we need to look at and think of how the transit IP node react to multi-hop BFD packet, which is, it does not have a BFD discriminator. So would it just forward it further?
It's
interesting. It's interesting idea, but I'm not sure that it will work.
We can discuss it on the mailing list over the draft. The draft is there, right? It's been posted. It details all this. And one of the big goal of this draft is to enable to decouple the treatment from the transport ports, right? The goal is to signal the treatment at the layer 3 and let the application information, like the ports, to the application so they do what they like. Now we should discuss that on the mailing list. I don't want to clog your discussion. Okay. Please look at the draft and let's discuss on the ML. But going all the way to UDP is a poor idea for Silicon.
Yes, thank you. Okay, so for the sublayer OEM, the proposal is to use Mpls in UDP. So we have the outer UDP tunnel, and then within it, we encapsulate as we encapsulate DETNet for Mpls network, and thus it will give us DETNet control word and for OEM DETNet ACH. And then we can do the pre-auth OEM in terms of discovery and function verification. And if we go next slide, so this is more specific what's defined in DETNet for Mpls data plane, their modified ACH word. So as you see, it's different from DETNet control word. First, it's by the first nibble, it's 1, comparing to 0 in a DETNet control word. And then we're modifying from the ACH defined for the pseudo wires with a new version number and then a new format. So to support DETNet sublayer OEM operation. Okay, we have about 2 minutes for questions and comments. Thank you.
Any further questions, comments? Okay, then let's move on to the next presentation. Young, you are present?
Hello, can you hear me?
Yes, I hear you fine, and I give you control over the slides, so you can...
Okay, thank you. My name is Jinu Jung. It's nice to present here. This is about the asynchronous deterministic networking framework for large-scale networks.
If you could speak up a little bit or go closer to your mic, that would help us hearing you better.
Oh, okay. Okay. So it specifies the framework for both latency and jitter bounds guarantee in large-scale networks with dynamic sources with arbitrary input patterns. Here, the large-scale means the network has arbitrary topology, and it may include loops. And the link capacity and the propagation delay may vary. The dynamic sources means flows join and leave freely. The arrival or input pattern is arbitrary, that is a periodic or random packet arrivals. Here the only constraint is the T-spec, the burst, maximum burst size and the average rate parameters. So this is similar to the internet. The overall framework tries to avoid time synchronization and to decouple the latency guarantee problem from the jitter guarantee problem. The latency guarantee is implemented or a bit done by mainly by the regulating functions, regulators. The jitter guarantee is based on three parts. The first one is the latency guaranteed network and time stamping and the buffering. The internet already has the solution for the latency guarantee in some sense. That is the DeepServe framework. But it is provided that in every link, the total high priority traffic rate does not exceed the link capacity. Or to be precise, every flow has to be serviced by the rate greater than its input rate. So the link capacity has to exceed in order for every flow has the guaranteed rate that is higher than the average rate. So the resource reservation and the automation controls are mandatory. So these are the out of scope of this draft. So the DeepServe framework works well for lightly utilized networks. However, when utilization is medium to high, the burst accumulates. Assume there are n identical flows coming into a switching node, each with parameter B and R. B is the burst size and R is the average rate. At every node, the burst accumulates as much as, according to their scheduler type. The B out here is the flows burst size out of that node. So anyway, the burst becomes larger. But you can see that the burst out is the function of the utilization and function of the other flows burst, or sometimes it is a function of the other flows maximum packet length. So they can vary a lot, but anyhow, they increases. Now the flows are with new parameter B out and R, and this accumulation continues as flows travel. Now, if there is a cycle in network topology, it acts as a feed-forward loop. Then the burst explosion phenomenon occurs, and the latency guarantee no longer holds. So these solutions to mitigate the burst accumulation, there are quite a lot of solutions, I would say. The slotted operation, maybe without strict synchronization, can be the solution. And metadata-based packet forwarding, such as the latency budget, etc., can be also a solution. And the flow regulation, that is the direct solution to mitigate the burst accumulation. It is to force a flow into its initial shape. They have their own shortcomings. For example, the slotted operation or the cyclic queuing, either strict or loose, requires the slot planning and the source cooperation. And moreover, the cycle time can be as large as the accumulated burst size because it may have to accommodate all the other flows in its path. The metadata-based forwarding, it has many variations, I think. May disperse, but sometimes may not disperse the accumulated burst. And it requires the lookup, the metadata lookup, and decision based on the metadata and the node state, and queue reordering and overwriting the metadata at the departure in line speed. These are required. These are required. In the meantime, the flow regulation has its own shortcoming. It requires flow state maintaining. But we argue that this can be overcome with the flow aggregation. So here the regulation of flow aggregate is suggested as a solution. The first such example is the ATS, IEEE and ATS. It is based on the interleaved regulator, which has the nice property that the IR does not increase the worst latency of the FIFO system. So the FIFO system must be given in front of the minimal IR. It can be implemented in the fixture on the right side. The ATS has to be implemented at every node. An IR per input port has to be implemented. But IR has only one queue, but still requires individual flow states. The second solution suggested in this draft is the FAIR. It represents flow aggregate and IR. It is basically a generalized ATS. Here, the FIFO system is suggested as a network domain called aggregation domain, or AD in short. So FAIR, the regulator is implemented at the AD boundaries. And the flow aggregation is defined as a set of the flows with the same path in the AD. It has been shown to work better than ATS in the academic paper. Third, another solution suggested here is the port-based FA regulation. It can be implemented at every node or only at the critical links to break the cycle. Here, the flow aggregation is the set of flows having same input-output ports of a node. And mainly, it regulates flow aggregate, not individual flow, based on the parameters of the sum of the burst size and the sum of the average rate. So it's kind of a loose regulation. So it has the best scalability, no need to maintain individual flow state. And it has been shown to work almost as well as the ATS. There are other possible solutions not specified in the draft. For example, more strict regulation than TSPEC suggests can be a solution as well. Here, the regulation is based on the parameter L and the summation of the R. So regardless of the burst size, the TSPEC suggests the regulation can be very strict. And in that sense, it can be seen as very similar to slotted operation or cyclic queuing. Another possibility is to use the forwarding metadata, such as the source timestamp, to reproduce the initial interruptible process at every node. So there are lots of possibility in this framework, I would say. Finally, based on those latency guarantee framework, we can also guarantee jitter upper bound. Here, the jitter is defined as there is a, okay, so I would say the jitter guarantee is reproducing the interruptible process with the inter-departure process of a network. So provided that we have the latency guaranteed network, we can timestamp at the network boundary near the source. And based on this timestamps, we can buffer the packets to reproduce the interruptible process at the inter-departure process. Um, yeah, it has been shown, it has been proved that the jitter is upper bounded, and the end-to-end buffered latency is also upper bounded. We can control the jitter bound. We can even have a zero jitter. In that case, the end-to-end buffered latency is almost twice as the end-to-end latency bound. It has been proven. Sorry for the time passing. So thank you. Please look at the draft. Comments and questions are very, very welcome. Thank you.
Okay, thank you. This is actually our first document on sort of this new area where we're looking at enhanced data plane, queuing mechanisms, and changes in how we can support traffic treatment in DETNet. And that's the term that was used in the charter. It's a new area for us. We're very interested in the contribution, so thank you. And thank you for that we have a number of presentations on this topic, so that's great. One thing to keep in mind is there's a sort of a theme throughout a number of these solution documents that talk about changes to the data plane. I think this draft used the term metadata that's sort of used in others, but there's a common theme of some extra information that's needed to support the enhanced queuing and enhanced traffic treatment. And one of the questions for the working group is going to be, do we want to identify a common one? How many of these do we want to put forward? And this is just something, we don't want to discuss it right now. We just want to put that into your head as you hear the different discussion. And we are going to be asking about if you are interested in hearing more on each of these topics. So I really don't, I see Torlis getting up. Torlis, I don't want to have a long discussion about this. I want to give time for the presentations. We had one question on the last one, so why don't we go there? And then we'll move to the next. So, who was first?
So Lin Han from Fishway. This is very interesting work, and I think it's very important for the DETNet applied to IP network. But I have a couple questions here. So first, what is the definition of flow here? Is it IP or Ethernet? Okay, second question is that you're using regulation or we call traffic shaping. How do you get the rate? By provisioning or by whatever methods?
I would suggest that it'd be best to put this to the author on the list. They're not in the room, and they went over a little bit. They were nice enough to apologize for going over, but they really didn't need time for questions on the document.
All right.
Please send it to the list. Shusang was next? Yeah. Shusang? Shusang, you had a comment?
Hi, can you hear me well?
Yes, thank you.
Two very brief question, just for a clarification. The first one is that because we have another document called bounded latency, so I think that this document is really very related to that one. So the question is for the authors, what is the relationship of these two documents? I understand that this document mainly focus on the asynchronized case, but I think it's still have to deal with the relationship with the existing document. And the other question is that I noticed that this document is called a framework of the asynchronized maybe shaping or scheduling mechanisms, and it listed a set of mechanisms that could be used to provide bounded latency or bounded jitter. I think that is a very great work, and it could be a good start. But it is still a question for us: what is the relationship with the existing mechanisms defined in IEEE? Because as we discussed before in the working group, there are a lot of existing work that has been discussed for a long time in IEEE. So if we have done similar work in DETNET, what is the method we can synchronize with IEEE people, and how to cooperate with them? I think that will be another question from me. Thank you. It's a meaningful work, I think. Thank you for the contributions from the others.
Okay, thank you. I'd like to ask again, take it to the list. We're 5 minutes over on this one, and there's others, so we're eating into other people's time.
Just a quick comment on what you were saying. To better compare, maybe at some point in time we want to, even have some summary of alternatives or the structure or something, to just not have a long list and don't even know how to do it. So, for example, the biggest two buckets I can think of is one of the solutions where you can get better DETNET treatments by just relying on existing packet headers that we have. Effectively, I think that's what we've been hoping by doing, to be able to attach state to the 5-tuple or 6-tuple flow elements. That is implying maybe we can even just have whatever the stolen from TSN queuing discipline, and we don't need to treat anything in the forwarding plane. My proposal here also tries to do that trick to quicker get deployed, and the other ones do cooler things by having new packet headers. So that's one big areas of distinction.
Yeah, and going to Shusang's point, we sort of do expect that there's going to be some falling out, maybe some consolidation between these things that are, it may at first seem pretty separate, but they're aiming towards the same place in some cases they're not. But hopefully we'll see some consolidation as well. All right, thanks. We should press.
Yes, move on to the next one. Kwam, please. You have the control, and go ahead.
Hello, I'm Chuan Sheng from ZT. I would like to talk about the DETNET enhancement for large-scale deterministic networks. Next slide, please.
You have the control to click the next slide.
Okay, thank you. Okay, so first, the background is that the latest working group charter was updated in July. Packet treatment-related methods should be supported in data plane. The milestones show the document plan of DETNET WG in the future 2 years. Enhanced DETNET is the next focal topic. So, next slide. We will talk about some problems need to be discussed first. What is the enhanced DETNET? From charter and milestone, the enhanced DETNET is required to provide the enhancement of flow identification and packet treatment, and support the enhanced functions or mechanisms for DETNET data plane to achieve the DETNET queues. So what's the enhancement of packet treatment? As per RFC 8938, DETNET-related data plane functions must be decomposed into 2 sublayers, a surface sublayer and a forwarding sublayer. So DETNET-specific metadata and DETNET IP Mpls data plane has been described. So in my view, for the enhancement of packet treatment, the treatment functions for DETNET data plane should be described, and treatment-specific metadata and encapsulation should be defined for the DETNET flow. For requirements, the enhancement requirements has been discussed for several times, including technical requirements and the data plane enhancement requirements. And what's more, the requirements from perspective of surface sublayer and forwarding sublayer has also been described. For example, the deterministic surface may demand different deterministic queues requirements. Deterministic routes should be established, and the distributed routes and the inter-domain routes should be taken into consideration, and the resource should be managed to provide binding latency guarantees for the deterministic forwarding. So some of the queuing related and the data plane requirements have been merged in the large scale requirements. So for the data plane, the enhancement for the data plane is shown on the right. Right side, contrast to RFC 8938, the enhancement in the enhanced treatment functions may be added, such as flow aggregation, flow
Sorry,
redundancy.
you show a different slide, not the one you are talking to. We see page 5 here, and you are talking to page 4.
Oh, sorry.
No, it's the one. Okay.
Okay, I will continue. So for the data plane consideration, we think the enhancement for the data plane should be enhanced, shown on the right side. Contrast to RFC 8938, the enhanced treatment functions may be added, such as flow aggregation, flow redundancy, and the surface level aggregation. And for forwarding sublayer, maybe multiple queuing mechanisms, deterministic paths, resource scheduling, distributed routes, and so on, and many functions to improve the deadlock performance to achieve the deadlock queues. And the treatment metadata used by functions should be carried, such as the surface level information, aggregated flow information, redundancy information, path information, queue information, and so on. And many other information can be added to the metadata. And then the encapsulations format, such as IPv6, RSOV6, and Mpls, should be taken into consideration. And then particular requirements for the controller plane should be taken into consideration according to the enhancement of the deadlock plane. So we list out some requirements for controller plane, such as management and scheduling over resources, distributed deterministic paths, and interdomain deterministic path, deterministic path calculation, and so on, and other requirements to be discussed in the future. So the solutions over enhanced treatment functions and metadata are open to working group. We call for co-authors and reviewers, and hope to provide a more visible and achievable way to progress this work. Comments and questions are appreciated and welcome to join us. Thank you.
Thank you. Shasong, please go ahead with your question.
Hi, Xuanxuan. Thank you for your presentation. Could you please go back to page 5? I think my first question is also for the chairs, because page 5, Chuan has mentioned some requirement for control. Page 5. Next slide. Thank you. Yes, you mentioned some controller plan consideration. Actually, as the author of the controller plan framework, my question is that whether the existing controller plan framework is supposed to only contain the DETNET controller plan requirements and some framework considerations, or we should also consider the enhanced DETNET controller plan consideration. If we go to the previous method, maybe there will be another document, maybe called controller plan considerations or framework for enhanced DETNET, as listed in this slide. But if we go to the latter method, maybe it can be combined into the DETNET existing framework. As the author, I prefer the latter one, because the controller framework controller plan framework document itself is still under discussion. So we would like to combine the considerations of enhanced DETNET.
Yeah, I think the existing contour airplane document, the contour airplane framework, is a working group document. It's being developed, so we can add the material right now as we progress. I don't see issue with that.
Okay, thank you. And the second question is for page 4. I noticed that here you also listed some enhanced DETNET data plan requirement for service sublayer. For example, flow aggregation, flow redundancy, and the service level aggregation. All these functions, I think, that have already been defined in previous DETNET discussion. So my question is that what is new here, or what should be enhanced here for service sublayer?
In my view, the RFC 83 and 89 has been released, and some of the functions or some of the encapsulation has not been covered in that RFC. So, in my view, the additional functions or encapsulations all belong to the enhancement. So it's up to the data working group. Thank you.
Yeah, I think we could look at some specific text and see which parts are line up with what has already been published, as well as what other documents are coming into the working group. For instance, you mentioned the requirements document, the individual draft, and we do have on our milestones adopting such a requirements document, and it seems like some of the text you described in your draft could go to that document. And perhaps as we start looking at the specific text, some of them we'll find already exist in RFCs, and others will maybe go to other documents. So we might end up realigning and redistributing as we move towards working group adoption of solution documents, as well as the architecture document. I'm sorry, requirements. Thank you. And we should move to the next. I think it's the same presenter.
Yes. So please go ahead with the next presentation. You have the
Okay.
control again.
And please watch the time as well.
Okay, thank you. This is about the deadlock queuing option. Sorry. So we just discussed about the enhanced deadlock. The data plane we should provide the functions to achieve the deadlock queues, such as end-to-end deterministic latency. So what is the end-to-end deterministic latency? As per IETF deadlock banding latency, the end-to-end band can be computed as the sum of low queuing delay and the queuing delay along the path. The upper down bound of no queuing delay are constant, so the end-to-end latency depends on the value of queuing delay. Along with the queuing mechanisms. So the queuing information should be taken into considerations in enhanced deadlock data plane to realize the deterministic latency. And how to ensure deterministic latency? First, we should provide the functions or technologies to ensure deterministic latency, such as queuing mechanisms, and carry the related information in the data plane. And the second, we propose a common queuing option, and the generic queuing information should be carried in data plane metadata. And finally, Mpls, IPv6, SRv6 encapsulation should be taken into consideration. So for the requirements, the enhancement requirements has described that it is required to provide information used by functions ensuring deterministic latency and define the related metadata to help regulation and the queue management. And the large-scale enhancement also proposed that the enhanced datalet data plane is required to support a method over packet treatment, and that will include the deterministic latency scheduling. The packet treatment should support the queuing treatment and the identification of queuing-related information. So multiple queuing mechanisms can be used to guarantee the deterministic latency for various application in data networks. So it is required to carry queuing information in data plane to make a point packet forwarding and the scheduling decision to meet the 10 bounds. And so the queuing information, we list out the queuing mechanisms which has been discussed in datalet. That should get a confirmation from a working group. But for the first of all, an unique queuing mechanism should be selected in enhanced data plane. That could be selected to guarantee the latency. For example, the TAS, CBS, CQF, ATS, cyclic queuing, deadline-based queuing, and ADN. We just talk about. Second, the queuing information may cover the planned and required queuing delay, such as maximum queuing delay and the maximum queuing delay variation. And the queuing parameters should be carried for the correlation between nodes. For example, the cycle information, deadline information, and the latency, budget, and so on, and many other parameters will be added to the queuing information. So we proposed the IPv6 extension solution to provide the absolution for the queuing information. We define a new IPv6 option for that to scale queuing information. And we define the queuing flag helps to discriminate the types of queuing mechanisms. We use subtheory to carry specific datalet queuing information, and we also specify the format that the new option is to be placed in an hop-by-hop or DOH extension header. We also proposed the Mpls extension solution. We provide additional encapsulation for the queuing delay over datalet flows in Mpls data plane. We align with the ongoing work in Mpls working group. This IETF Mpls MNA framework that has been just adopted as the working document. So we propose to add SPL to carry datalet queue, redefine datalet queuing indicator in SPL, and use TLV to carry datalet queuing information, and use sub-TLV to carry specific datalet queuing information. So the types of queuing mechanisms used for datalet and the related queuing information should be discussed in details. That should get confirmation from a working group. And the last steps, other encapsulation such as Mpls over UDP and SRH may be taken into consideration, and we will follow the charter and the milestones of datalet and align with the terminology. So comments and the questions are appreciated. Thank you.
And we have time for some quick questions. So first up is Greg Mirsky. Greg, you're in queue. Did you leave the room?
So I realized that you propose to have this queuing information that includes time budget for the packet be included either as a hop-by-hop information or end-to-end. What you envision the system behavior if their time budget for the node is exceeded?
This is up to the Ulicker queuing mechanisms. So this draft just proposed the scheduling over multiple queuing mechanisms. So I think what you ask is belong to the queuing mechanism, not the scheduling.
So
But
we really,
my understanding
over
the draft
time,
talks about guarantees, so then there is no guarantee, I guess. But let's take it to the list. Thank you.
yes,
Thank
please.
you.
So we are really over time. I don't know if you can take it to the list, that would be the best.
Sure, I think my question is similar as the guys. Right now, the talking about coding is too early.
So we're actually you're jumping the queue. So if you don't mind taking to the list, that'd be great. Robin, if you don't mind taking to the list as well. Thank you. And I think Torlis, please. And we're going to steal a little time from you and the next presenters. It's not just you, it's the next presenters also.
All right.
Thanks.
So this stuff has been around for 5 years through different drafts. Next slide. Faster. All right. So there is a very long draft that I wrote with all the nasty and interesting background. It expired. If you're interested to have informational or even individual for that draft, let me know separately. The requirements are also integrated in the active draft that carries it as requirements. This is all the good stuff. This solution does bounded latency, DOE, right? Minimum jitter, that's the most important part. Synchronous industrial control loops and other stuff. And also it makes end devices cheaper because it removes the clock synchronization requirement from them. Arbitrary links and jitter, which is what TSN doesn't need. And then the big thing, it scales because it doesn't have per hop flowing state. So it's not per hop 5-tuple state, even though it just then has the latency DETNET services. And so all the good things that come with it, like, no interruption during network reconvergence and so on. Minimum clock synchronization requirement, proven mechanism. So this is basically TSN, cyclic queuing and forwarding, adopted to DETNET. And no change to the packet headers is one option. We can obviously, as you saw, these cycle stuff also put into new headers, but we don't need to, especially not in the MPLS forwarding plane, which we already have. So makes it a great, first step mechanism where we don't only have all the queuing stuff well worked out, but also no packet headers and no coffee for it. Next slide. Okay, how do we do it? As I said, cyclic queuing and forwarding from TSN, well proven, understood, meets all the requirement except for number 5, has a very high clock synchronization accuracy requirement because it synchronizes on nanosecond clock, which we don't. And the throughput for that stuff goes quickly down to 0 when you have network path longer than, let's say, 2 kilometers on the typical parameters. So with tagging, we're synchronizing based on a tag in the packet header, which we need 3 values at minimum. So that would be MPLS encoding 3 values of the traffic class field. This is in the draft. And the validation that we've done is based on 100 gigabit FPGA 3-4 years ago. Production routers with additional QS FPGA, and that was deployed in a 2,000 kilometer network in China across multiple parties to validate that this is running fine. And as I said, proposed since then, but obviously not on the charter, so always waiting in some way, not deterministic queue. Next slide. Okay, so this is, I'm going to skip this, right? So this is the mechanism. This is when we ever discuss the details of the technology. Next slide. So what did we change since 113? So we added a reference to the 2021 published research paper that is showing all the gory details based on a highly accurate simulation, so it's a lot easier to do a lot of timing validation in the simulation. This is an IFIP conference, which means there is no paywall. The URL is here. We edit the text in forwarding pseudocode for the ingress operation. When you get your 5-tuple flow and you do per 5-tuple flow and queuing into this non-per flow forwarding mechanism. The way the spec is written, this is all done based on textual plus pseudocode. I come from a multicast world, so a lot of RFCs in multicast routing have been defined on pseudocode. I preferred over some of this diffserv behavioral description that we've seen in diffserv. So that's, you know, for us to decide how we write these texts. And that's very simple, right? Every flow just has a certain amount of configured bits that it can enqueue into every cycle. Has to be larger than a single packet, of course, and the pseudocode explains that. And then I added more implementation, deployment, validation considerations for high-speed implementations for network with different speed links. So next slide. So I think, you know, from what I think we need to achieve in a draft to actually get to a point where we can approve, build, and deploy it, it's functionally complete. Obviously, you know, not a lot of review done. The charter puts it into scope, I think. As I said, it can be done with existing packet headers because we just need a few values for the tag in each header. Mpls is what we've defined. If we put it into DSCP, we can do it for IP, where we may not have, you know, worked out all the DETNET service stuff in the architecture by itself, which is trying to tunnel it over Mpls at this point in time. That might be an additional text. And then, of course, yeah, how do we want to structure this stuff? I was talking with Ishan in Vienna, and he was saying maybe separate out the mechanism independent of the tagging in MPLS or DSCP or so. But that might be an informational document. So I was in the first place trying to go, what's the minimum? One document has the MPLS in it. We do an add-on document in TSVWG or DETNET for DSCP. So that's all structure. In the end, I think it would be great if we could do an adoption call, right? This is uniquely different from all the other things that are being brought in right now, because I think it hits all the check marks of, you know, high-speed validation, being around long, being derived from proven TSN technology, and, you know, meeting all the requirements that I could have ever think of and written down in a requirements document. So thank you.
Thank you for leaving time for questions. We have a few people in queue.
Thank you for reviving this. Reusing, just from a basic stuff, reusing the existing data plane mechanism simplifies any deployment, because trying to bring any new forwarding mechanism into the data plane puts in a very long cycle before we can see any results that can be put into commercial offerings.
It's mostly an IETF issue, right? Because the real challenge of all the QS we're doing is some form of FPGA to do really cool new DETNET queuing, right? So,
but if we can reuse something that is already there and it does have to be FPGA, it's already in the ASIC, then why not?
If you're lucky, if you have an Ethernet switch that is TSN based, maybe that makes it a lot easier. Yes.
There are ones available that are commercially available. So that's
well, we've been trying to look into this with P4, and we're still struggling with the, you know, it's not a P4 TSN switch. Yeah.
Okay. There are Taiwanese vendors that are providing you Broadcom with the functionality that you're looking for, and they even give you the PTP if it's needed. So they are. So if this gets adopted, there is commercial hardware available where this could be implemented.
Cool. Thanks, Dion. That's important feedback. Xiaofu?
Shafu, please go ahead with your comment, question. Let's move to David. David, please.
Hi, Trellis. David Black. Loaded question. What's the scope of this?
Sorry.
Oh, wait a minute. Did we get Xiaofu on?
Yes, Xiaofu, please go ahead.
Yeah. Okay. My question is if we observe a network intermediate node which may receive concurrent Cqf traffic from multiple incoming interface. So assuming that all this traffic are expected to be sent in a single cycle at the same time, the problem is how to ensure that the sum of this traffic will not exceed the maximum number of bits that can be sent in a single cycle. If it exceeds, is there any compensation scheme by Tcqf?
Can we take the
Thank
question to the list? Because I think it's really hard to understand you here, so it would be great, and I'll answer immediately. Thank you.
Okay, no problem. Thank you.
Thank you. David?
Okay, David, but loaded question. What's the scope of this?
You know, I would say replace TSN, but obviously we want to start with the, you know, where the network becomes larger, where TSN doesn't work well, right? So this could be...
I'm asking a different question. How many administrative domains?
Sorry?
How many administrative domains? And Lou knows the answer. Let's see if you know it too.
Right.
The answer is one.
Yeah, of course.
Okay, so I have good news for you. You do not need TSVWG's permission to go forward here. Within a single administrative domain, DSCPs are generally usable at the operator's discretion.
Right.
It might be worth talking a little bit to TSVWG about how to select some DSCPs will cause less trouble, but you don't need to write up a full diff serve RFC.
That's good. Yeah, you're right.
So I think Dan is going to come to the mic and say, you know, it allows you to reuse the existing formats, and there's going to be huge value in that. And then we should move to the next person to allow them to
Okay.
We're on the same page. That's right. Dan Draganovich, channeled by Bluebird. So next up is Hal, and I
Yeah.
apologize if I mispronounce your name.
Yeah, I'm Ijo. Thanks. So I just realized that this one actually possibly would be best to put before Tola's presentation. So it basically talks about the similar thing, but it gives a little bit background and the reasoning why this kind of tagging or the cycle ID would be required in order to enhance the CQF. But this one is more focused on the IPv6 data plane rather than the Mpls. So let me try
You
to
have the
control
control
it.
to move the slides.
Yeah, I just realized that. Yeah, so quickly try to refresh the memory. We have the fundamental Cqf, which was defined by IEEE, and I'm not going to touch the details of it here, but basically the fundamental Cqf has two buffer per port, and the input and output was swapped once every cycle time TC. So this cycle interval TC is very important, and also as given by the working group document bounding latency, it has been shown that the minimum end-to-end latency and the maximum end-to-end latency basically are determined by the cycle interval TC and the number of hops. Of course, here we have a dead time terminology defined. I will revisit this later. But in the fundamental Cqf, the dead time DT value is really small, so basically it can be negligible. So that gives very attractive simplicity features from Cqf, which means that it gives the simple calculable latency bound, which only relevant to the cycle interval TC and number of hops, and also it gives the simple maintainers. Those are the attractive features that people want to consider it for the wider deployment. And we are also seeing that the CQF has the potentials for the wider deployment. When we talk about the wider deployment, basically we're thinking about at least four features to be supported, which are labeled as 1, 2, 4 under the first bullet. Namely, they are the smaller end-to-end latency bound. The second one is a larger number of hops. The third one is longer links, which means the longer propagation delay. And the fourth one is the larger processing time variance, because we are expecting the different node types will be put as the intermediate nodes, such as different switches or routers from different vendors, or even some of the layer 1 equipment which are not visible at the layer 2 or layer 3 layer. So recall that the CQF latency bounds are only relevant to the number of hops and the times and the cycle interval. So when we talk about these 4 requirements, the first 2 we are thinking they naturally can be supported by the higher speed links. So there is a hard requirement that for each of the cycle, it has to at least support a maximum size packet, which is normally 1500 bytes. So look at the table here. It basically gives when the link bandwidth increases, we can achieve the smaller cycle time in order to send one maximum size packet. So that gives the potential that the cycle interval can be decreasing from a few hundred millisecond to a few millisecond. Sorry, a few microsecond. So we are seeing that the potentials for the item 1 and 2 basically can be achieved. So let's talk about item 3 and 4, which are the longer links and the longer time variance. So if we look at the fundamental 2-buffer CQF, we are thinking that it can support the requirement 3 and 4, but it will encounter the low utilization issue. So here we want to revisit the dead time, which imposed by the fundamental CQF, which is in the red box here. We can see that basically the dead time is a time to be put normally at the end of a cycle. It's the last byte. The purpose of it is to make sure that the last byte sent by the node A in the cycle I minus 1 has to be ready for sending at the next node, which is node B here, before the next cycle, which is cycle I here. So basically the dead time should be at least the sum of the maximum propagation delay between 2 neighbors plus the maximum processing delay at the next node, and also some of the other time variance, for example, like the clock shifting, something like that. So the longer the propagation or the processing delay, the larger the DT. So if we want to achieve the lower end-to-end bounded latency, that means we have to use the lower cycle interval. So that basically means that time will eat up the cycle interval when the cycle interval is small. So that's why we see that the low utilization here by the fundamental CQF. And the CQF variant is introduced. Actually, it's not a brand new idea. It has been brought up from time to time. So here we indicated here the CQF as a 3-buffer. So the 3-buffer works in rotation manner. So it's a straightforward variant to the fundamental 2-buffer. The configuration is very similar, and the logic can be easily deduced from the fundamental 2-buffer CQF. We don't think there is a rigid requirement to produce a new standard. And it is in general, it's feasible. But when we take a closer look at the CQF variant, we find out that there is a time ambiguity window exists. As the diagram at the left show, we see that there is a processing time window here. It swells because we want to support the larger processing time variance. With the increasing of the time variance, we can see the degree of the swelling is more severe. So the time ambiguity window will exist for 2 consecutive cycles from the node A. So which is here, it's a little bit smaller, I guess, but if you can see it, there is an ambiguity window here. So basically, the larger the time variance, or the smaller the dead time, the larger will be the ambiguity window here. And remember that in the CQF, normally we need to preset time demarcation to differentiate the packets from 2 consecutive cycles. Then in here, it would be impractical because the blue dashed line, if we set here, then it looks like for the case 1, the green and the red packets which are from different cycles from node A, they are perfectly demarcated. However, maybe for the next round, there would be again ambiguity. The leftmost red box here will be wrongly identified as the green one actually. So a simple, a straight way out is to let the packet carry the cycle ID as the metadata at the output to help the downstream node to determine which one is the correct buffer to put it in. I think I'm running out of time. Yeah. So so here we have showed the packet IPv6 option format, but I don't think that's the most important one. We want to solicit feedback to see whether people think that the right way to address the ambiguity issue in order to facilitate the increasing demand to use CQF and its variants in the wider deployment. And also we want to solicit feedback and also from chairs if we want to define IPv6 options, whether and how to collaborate with other working groups. Yeah.
Yeah, I think it would be good to try to collaborate with those others who are working on similar topic. And we'll have to continue discussing this and other solutions in the group. And with that, Xiaofu? Oh, 7. We seem to be having a problem with the slide, so we're going to skip to Fan, and we'll find it. We'll
Okay.
fix it.
Can you hear me?
I think we're having trouble with your slides. Just hold on one moment. No, yes, we have it now. It's coming. Okay, please proceed.
Okay, thank you, Chair. Thank you. I'm Xiaofu from JT. I will introduce the scheme about the deadline-based scheme forwarding. Next, please. Okay, I can control it. Compared to last version, the following updates first modify some nonce for ease of reading. That is, planned deadline is changed to planned residence time. Actual dwell time changed to actual residence time. Accumulated deadline deviation changed to accumulated residence time deviation. And second, further elaborate on the scenario of partial upgrade. So for motivations of this document is that DETNET defines the goals of deterministic routing. The bounded delegate packet loss ratio out of all the delivery. Use resource reservation, explicit routing, and service protection to achieve these goals. Well, resource reservation is the basis of ensuring bounded delegate, and ultimately depends on the queue mechanism of the forwarding plane. The issues of candidate mechanisms for large-scale packet network. CBS and ATS come with a high latency variance because the minimum latency is not affected by this mechanism. Cqf is quite challenging because it requires time synchronization. Anyway, maybe some other Cqf-based variant. The widely used priority-based queue scheme may give better average latency, but with worst case latency. So this document proposes an enhancement scheme of PQ to adaptively adjust the sending authority according to the planned time and uniformly consider bounded delay jitter. So this is a overview of the total scheme. We introduced deadline forwarding mechanism using queue data structure. Deadline queues are variants of PQ and are also based on priority scheduling. All deadline queues have TDL attributes staggered from each other, decreasing with the passage of the time I. The deadline queue with TDL 0 has the highest priority. After the authorization time for sending, it is TDL will be reversed to the maximum initial value. The deadline queue with TDL non-zero has a normal priority if in-time mode, or prohibition priority if on-time mode. The former can be involved in scheduling, while the latter cannot. The following is a simple example of deadline queues. It contains 4 deadline queues. So how to put packets to deadline queues? First, get the deadline information of the packet, mainly including the planned residence time and the accumulated residence time deviation. This information can be gathered from a packet itself, or figure entry, or policy entry. Please refer to deadline option in 6-month working group. Second, put the packet in the specific deadline queue. We need to compute the allowable scheduling delay. It is equal to the planned residence time plus the accumulated residence time deviation minus the internal forwarding delay. The following figure shows that the 2 packets is how to put to the deadline queues. So traffic regulation and shipping. Traffic regulation and UI interface to ensure that the bandwidth consumption of service within the burst interval complies with its traffic specification. For example, data rate. At least we should do bandwidth management for multiple source. For n source, fine should meet the sum of data rate of each service must be less than the port bandwidth. Other resource management will be provided in later versions. Traffic shipping is performed on NNI to distribute the packets into deadline queues. The following figure shows that 6 packets from the same deterministic service are received on the UI port. Assuming that they arrive at the outgoing port one by one after intra-node forwarding delay, each packet will enter the queue with TDL value consistent with the allowable scheduling delay queue of the packet at its current time. For partially upgraded scenario, a deadline path may consist of several upgraded border nodes, for example, R1, R2, R3, R4, and the traditional SP path in the domain. SP path should contain few hops with the worst case latency per hop given by the paper SP latency. The Linux device in the SP path does not support deadline scheduling and may or not merge and insert the deadline information in the packet. The former record in the deadline aware nodes and the later record in the deadline unaware nodes. Internal mode is similar to SP latency. However, compared with SP, the board node can scale in packets by deadline information other than traffic class. That means a packet we node always experience the worst interference delay on every hop. The deadline we node overestimated the worst case delay on each hop, like SP. The effect of anti mode is similar to Cqf or traffic dumping. The packet will be delayed and the board node to achieve the JIT target. So what's the benefits for this enhanced scheme? For cost, time synchronization is not required between network nodes. Operate based on the relative time. States per flow or flow aggregate is not required. For deployment, a packet multiplexing base is an enhancement of PQ scheduling algorithm, easy to upgrade. Each node can independently set authorization time of the deadline queues based on self-port bundle widths and support partial upgrade. For scalability, a single set of deadline queues support multiple levels of residence time. Queues with a higher maximum TDL can be created incrementally according to service needs. For performance, good JIT control, just a single authorization time. Any questions and comments? Thank you.
We're sort of out of time, so I know Torlis is in queue. No, wasn't Torlis? Was someone in queue and then left? But you left. Thank you. So we really don't have time. I'd like to discuss this more on the list. If you can take your comment there, I'd appreciate it. And with that, the last person on this particular topic is Fan Yang. One moment, we're having a little bit of a problem.
Okay, I see the slide. This is Fan Yang from Huawei, and I will present this .NET enhanced data plane. I think I can flip. Yeah, here's the simple logic that why we have this draft. First, according to .NET architecture, .NET is required to support bundle latency. And right now we see there are already several mechanisms proposed in .NET to support the bundle latency. So in the short feature, that people envision that .NET data plane should be enhanced to support the bundle latency, which is specific. Specifically add the bundle latency specific metadata. To meet the goals of supporting the minimum and maximum end-to-end latency in .NET data plane, that the one .NET specific metadata flow ID is used to identify the .NET flow. But however, there's no other metadata defined to support the end-to-end latency. So we see there is a missing in the .NET data plane. And also, there are also other requirements to .NET data plane that defined in this requirement to the large-scale .NET draft, and including the functions, including the explicit inclusion of the metadata, and also compatibility to different underlying network technologies, etc. So to meet the goals and the requirements to support the bounded latency, that there have been several mechanisms that proposed to .NET to solve this, to support the bounded latency. And we list the mechanisms here on the left, and we think that if there are more mechanisms proposed, it should be added to this list. But of course, we think that it should be accepted or acknowledged by .NET first. So we have in this draft, we propose a new .NET specific metadata, which is called bounded latency information. It is used to be carried in data plane to facilitate that DETNET transit node to support the bounded latency transmission. And as it's shown in this figure, that this bounded latency information is transmitted across multiple DETNET transit node and used by the DETNET forwarding sublayer. And this page discusses the design principles. First, we think that this bounded latency information should be carried is targeted to be carried in the data plane to help the DETNET flow to map to the forwarding and scheduling resources, which the DETNET flow requires. This bounded latency information doesn't focus on the local mechanisms which equipment uses. And second, we believe it is good to have a uniform format to accommodate the different underlying technologies or mechanisms. There are two reasons for it. One is interoperability. To have separate format for each mechanism obviously doesn't help the interoperability. And second is the security consideration. If there is an equipment with non-standard algorithm inserted into the network, this bounded latency information should help the equipment either drop the packet or transmit without processing the packet. And according to the analysis to the mechanisms that shown in previous slide, we classified this bounded latency information into two categories, and they are shown in these two tables below. The requirement category summarizes the requirement from the DETNET services, and the equipment will use this requirement information to map to the resources. And the resource category actually is more straightforward. It indicates the local resources directly. And in this bounded latency information data field that we use BRI type to represent or indicate the type of the bounded latency information. If there are more, if there is new algorithm that accepted by DETNET, and if the bounded latency information is different from what we have in this table, that it will be added as a new bounded latency information type. And the format, actually, it indicates both the format and the length of the bounded latency information. And for the flag, currently we don't have any definition for this flag. It is reserved for future study, I think. Bounded latency information carries the actual information used in data plane. For IPv6 based DETNET data plane, that we define a new IPv6 extension header option called BRI option. And this BRI option can be encapsulated in either IPv6 hop by hop or DOH extended header, depending on the processing behavior. And there could be more than one bounded latency information appear in one BRI option. So similar to IPv6-based DETNET data plane, that in Mpls-based DETNET data plane, a new Mpls extension header called BRI extension header is defined, and the processing behavior and how to use it is very similar to the processing in IPv6. And also this BRI information can encapsulate it in Mpls over UDP IP-based DETNET data plane. And next step, we would like to have more discussions on this BRI data field, and we want to hear the comments and suggestions from working group. Thank you.
Greg, and I'll note there's a bunch of people behind you, so try not to go on too long. Greg?
earlier. What's the benefit of having this BOI information both as hop by hop and end-to-end option in IPv6?
Yeah, actually, if you look at the detailed definition about the BRI type, we have the different types of the BRI boundary latency information. Some of this type can is some of them some of the BRI is used in the hop by hop scenario, and some of them actually can be used by can be processed by the destination node. So that key so in that case, it is better to be placed in the destination option header. Yeah,
So
it's like
what happens if a particular hop spends more time than it's allowed? Packet gets
And I'd
dropped?
like to ask that the response go to the list. That's a good
Okay.
question. I'm interested in the answer too, but we have a few people behind you, running out of time. Fan, did you hear the question?
Yeah.
Okay,
We can take to the list. Yeah.
All right, Daniel?
The benefit to carry end-to-end the delay budget in the data plane when actually the transit node makes the forwarding and routing decision based on specific resource type or the specific mechanisms such as the queuing types. What is the benefit to take this kind of end-to-end the requirements the bounded latency?
I'm not sure I quite catch the question, but here that we define a format, and this format can be placed in hop by hop or at the end DOH. So this information can be played can be processed either hop by hop or at the end destination. So it depends on the algorithm that on the requirements of the algorithms. I'm not sure I quite catch the question, but maybe we can come back to list for more discussion here. I'm not sure I answered your question.
Okay,
Yeah.
I'll post the questions in the mailing list. Okay, thank you.
Okay,
thank
good.
you. And before Robin asks this question, I'm going to put up start a show of hands. I put in the chat that this was coming. Basically, we should keep in mind that our new milestone is to get a requirements document adopted. So with that in mind, I'm going to start this show of hands while Robin continues asking questions on the same draft. So this is the question is independent of what's being presented right now. It's on the requirements draft that was actually presented at the last meeting and referenced earlier today. So thank you, Robin. Go ahead.
Okay. In fact, my opinion is that for the enhanced data plane, we should not
Robin?
code. Can you hear me? Hello?
We think you have an audio problem. Farouk? Oh, go ahead.
Maybe a little bit louder.
It's okay.
If you hear him, Fan, if you could just reproduce repeat the question, because we can't hear him. Okay, so Drew, go ahead, please.
While Robin is coming, let me ask a quick question. My question is maybe to the working group and the chairs also. We have two documents from DETNET on PC agenda, and we had the documents on enhanced DETNET in Spring as well as in BGP. So IDR. So wanted to, I think from this meeting, I realized that this is very early work. I think you guys are still sorting things out. But just so that other working groups can catch on, if clear requirements can come in while you guys are developing that from the protocols, what are the clear requirements that you would have and the terminology, because right now we were seeing that even the terms used in the documents were very, very different, and it was a little difficult to figure things out. So just a request for the working group, think about that as well when you are developing this. Thank you.
So I think you're saying you really want this requirements document that we're talking about at the moment with the poll. So you really want to
Exactly.
have that already complete and include a terminology section that we use across our solutions. Is that correct, Dhruv?
Thank you. Thanks for phrasing it much better.
No, I'm just making sure I heard you correctly. So we have like the numbers, if I look at them, we have 67 who are on Meet Echo. We have participation, which is a little better than half, and we have about half who've read the document. So, you know, we clearly need people to take a look at this document. If you have authored one of the proposed solutions, take a look to see if your solution fits into the requirements. And I think Dhruv brought up a great point about language, about terminology. See if the terms you want to use are in the document, and start sending comments to the list. We really would like to mature the requirements document to the point where we can accept it as a working group document, hopefully even before the next meeting. We had hoped to do it before this meeting. The IESG took a little longer to give us a new charter, but we have that now, and we really want to start moving out, get the requirements in there, and then start getting some of the solutions there. With that, Robin, are you able to say
Is okay now? Is okay now?
Yes.
Okay. Sorry. In fact, as a quick comments, Zhenmin from Huawei. In fact, in my opinion, we should not expose the queue implementation information in the network layer and the IP layer. So based on this thinking, we think we need the requirement information or the resource ID to indicate the specific process for each node. That's my comment.
Okay, thank you very much. And with that, we're actually switching topics. And I believe it's Carlos. And Carlos, you're going to squeeze down to 8 minutes. Sorry.
No problem. Thanks. I probably will be even faster. So I'm Carlos Granados. I'm presenting draft on behalf of my co-authors, Alan, Murad, and myself. Next, please. Basically, well, the idea here, and we already had a presentation in.
We cannot see it still showing the.
Yeah, I have no idea how to get rid of it.
Dismiss somewhere.
No, I did it already. I did the dismiss already.
Start a new poll.
Oh, that's a good idea.
Raise your hand if you know how to get rid of the poll. That's many years in a row. Boom. Yeah, and we got enough.
Okay. So thank you. So the idea here is that we have been deadnet and RAW mostly, even though the architecture and the service model supports multi-domain, we have been more or less focused on single domain aspects. So we don't have any explicit discussion on multi-domain. Here I'm just copying the service model diagram from the RC. So the idea is to basically try to study, analyze what could be needed to be done to support multi-domain. That's the idea, to identify potential gaps, and if there are gaps, then discuss whether we need to do some additional work in the working group or not. This discussion started at RAW, and then in an interim, we basically we thought, or I got the request or the suggestion to move the discussion to DEDNET, as this belongs more to the DEDNET discussion. Please, next slide. Next slide.
I'm sorry.
No problem. So there are different scenarios where we need to have multi-domain support, where we have, for example, one host connected to a domain that is connected to a different administrative domain, and then there is another host there. There may be, I mean, in the draft we list some use cases potentially that where this may happen. One important clarification is that by domain, we mean administrative domain and or technology domain. So we may have a wired domain connected to a wireless domain, and this is also multi-domain, even if those two domains belong or are managed by the same administrative domain. So as I mentioned, the goal is to explore what are the potential gaps in the architecture, OEM mechanisms, control plane, data plane, and then if there are, to identify potential solutions. Next slide, please. So the draft is very simple at this point. We basically try to identify some very high-level things where we need to take a look from the application, control, and network planes. So in the application plane, in the DETNET document, we have this user agent, which is the application, the entity that is interacting with the user and the operator and performing the request for the net services. And if we consider a multi-domain deployment, that user agent may be aware or unaware that there is multiple domains. If it's aware, that could take care of the negotiation of the different services to each of the different domains. But if it's unaware of the multi-domain, then it will have to rely on the network to transparently take care of this. Next slide, please.
Can you just have a quick question? It's just a very simple one. Multi-domain is within a single enterprise or between multiple enterprises? That's a very big issue.
Yeah.
Which one are you just focusing on, a single enterprise multi-domain or multi-domain in general over multiple enterprises?
Both are in scope at this point, but it's to be discussed. I mean, yeah, there are different problems, different complexity. Here is just identifying gaps, not going into the solution.
Okay.
So then we have the control plane, which is according to the definition in the document, the aggregation of the control management planes, and we have the CPF, the control and plane function. And at that level, again, if we consider a multi-domain environment or deployment, the CPF sitting at different domains may need to interact, for example, to discover and authentication, negotiate. And depending on the application, on the multi-domain support provided by the application layer, we may need to do different things at the controller plane. Again, very high level, but these are the type of things that we need to get into. And additionally, RAW may be bringing additional gaps. That's also the discussion we are having in RAW in the different drafts regarding to the PCE coordination that may be required as well in a multi-domain environment. Next slide. And again, the same type of high-level analysis on the network data plane. In a multi-domain environment, nodes belonging to different domains may have to exchange information, and there may be potential need for protocol translation or abstractions, as different domains may not be using or offering the same capabilities because they are, for example, different technologies. And the same thing, OEM protocols may also need to be extended to support multi-domain operation. As another example, performing PO for parallel across multiple domains may also pose additional challenges, as the knowledge of the different domains may not be available at the one domain, and the data planes may be also different and offering different capabilities. And the last slide, please. So again, here the idea is to present this problem, very initial work. There are some gaps, high-level gaps identified, and to discuss or to get your feedback on whether this is something interesting to work in the working group. And if so, please join us in the mailing list, and offline we will be happy to take more people on board.
Rick Taylor, oh God, that's loud. Rick Taylor, speaking with my raw chair hat on, we would like this work to begin in DETNET. So if we'd like the resolution to start at DETNET and then raw to build on whatever happens in DETNET. But personally, I support this.
Thanks.
Dejan Bogdanovic, there is a multi-domain coordination needed, but based on my experience dealing with the enterprises and then some multi-domain coordination that we have from the internet, I would like this work to be focused for intra-enterprise, for a single, let's say, overall administrative domain, and they can have multiple subdomains, because I believe this work would get then too diluted, and by keeping precise for the enterprise, because the DETNET use cases are very much applied for intra-enterprise network. So that would be supporting this work, but would likely to focus for within a single enterprise.
Thanks.
Thomas Eckert. Yeah, so maybe split it halfway. So I think we'll only have one round of, improving forwarding planes. So, we have options that don't require it, but hopefully we'll get to one option. And then it would be good, which takes longer, right? But which would be good to be sure that we know all the candidates of what needs to be in the data packet header, even if maybe we don't know all the interdomain stuff, but we feel very strongly that some, forwarding plane stuff is required there. So, and then the whole solution, I would agree, kind of build it later.
Okay.
Torles, are you saying you want to have a wider scope or more narrow scope?
I was trying to say it halfway, right? So I'm saying.
Well, I mean, what's the halfway? It's like...
What is it? Have the cake and eat it too. Right. No, wait a second. So very short term, I think no forwarding plane header changes. Then we have one option, I think, for each of the forwarding planes to come up with a great new header, right? And either we figure out we make it extensible, or we're safe that we don't need to extend that header for example, interdomain case, right? So if the parameters we need for interdomain, we also feel safely we need them intradomain, we don't have a problem. If we feel there are parameters we need for interdomain, we're not sure about them, we'll have a problem. If it's just control plane, we can push it out.
All right, so thank you for the comment. We're actually out of time. I was in queue, so I'll make the comment. It's actually a chair comment. I'll point out that you brought up controller plane changes. The controller plane document is still an active working group document. There is no reason why you cannot suggest text about multi-domain that should be included in the controller plane document immediately. So please don't wait. You don't have to, worry about adoption of your document. Just take text that's appropriate and suggest to the list that it be incorporated in the open working group document. So thank you for the topic. Really appreciate it. Thank you all for a really good session, and we appreciate all the contribution and look forward to seeing you all virtually or physically in the next meeting. And a special thanks to all who participated remotely.